You know what would be awesome? If we could harvest power over the audio jack of a smartphone and use that power for a sensor that would be able to send something from the environment, and then we could send that information over into your phone once again. And so this is what we decided to explore for our final sixes project. One, we built an energy harvesting circuit, like I said, that would take power from your smartphone over the audio jack, and then we would use that power harvested to power a external sensor, like a thermocouple. And then after taking the temperature from the external environment, we will be able to send that information back into our phone and also measure and visualize it using an app found on your phone.
In this part of the circuit, we take a frequency plate over an audio jack, run it through this voltage harvesting circuit, and output a reusable DC voltage. We built a circuit to harvest power from an audio jack. Essentially, we take input voltage and step it up through a transformer, and then send it through this diode bridge to rectify it. More specifically, we get input from our audio jack, shown here, through this signal wire here, which gives us a voltage that looks kind of like this. But it's very small, so we have to send it through the transformer, which is essentially an inductor wrapped around another inductor with a 1 to 20 turn ratio, which turns our little voltage into a much bigger voltage. So this voltage we then need to turn into DC power from AC power. So we send it through this diode bridge to rectify it. So basically the path of current is down one of the sides and then back out the other side for positive, and then it does the same thing for negative voltage. Essentially it's taking the absolute value of the voltage, which turns our voltage like this into a voltage more like this. However, because when it goes through the diode bridge, the Schottky diodes draw about 1.4 volts from the circuit, and our voltage is already quite small, it ends up being a much smaller voltage. So ours actually comes out to look more like this, which is essentially what you'd get from a filtering circuit that we would normally add on to an AC to DC converter. However, the capacitor circuit for filtering wasn't necessary in this case.
So we initially had very lofty goals to have a very integrated system consisting of the power harvesting circuit and also the communication circuit back into the phone. But what actually happened was our transforming circuit was not able to provide us with the 1 to 20 multiplication that we hoped for. We ended up having a very low output voltage from our transformer that wasn't able to power our sensing circuit. So instead we had to split that into a separate system. And so for our sensing circuit, we built a voltage-controlled oscillator that took an external voltage input and used that to modulate the frequency of that circuit so that it could be communicated back into our phone.
So, I'm going to explain our voltage-controlled oscillator, this part of the circuit. And we decided to build a hysteretic oscillator, which is pretty simple. It just has resistors and capacitors. Okay, so the way that this voltage-controlled oscillator works is that we input some voltage to it, and that charges this capacitor, and the capacitor will end up discharging. So this part is the output. So depending on what type of what amount of voltage we put in, the frequency of the output is going to be different. These two resistors right here make up a voltage divider, so it goes from ground to the negative terminal of the op amp to the output of the op amp. And what we're doing is whatever circuit you attach to this voltage controlled oscillator, the little voltage that you're measuring is going to be input right here in the middle of this voltage control of the voltage divider. And because of that little voltage difference, the frequency of the output is going to be modulated. And that frequency is going to be sent through the microphone jack into whatever device you're using to measure. In order to simulate the voltage that we would measure and add in, we decided to use a potentiometer. And so what we did was just hooked up the potentiometer to a DC power supply, and as we changed the resistance of it, it would change the amount of voltage which was being added to the voltage divider, and then it modulated the frequency. And we're able to see those results, as you will see.